Download this code and get free GPT-4o from codegive.com, link in the description below. Distributed DDL Replication at Global Scale, a tutorial overview by Gwen Shapira. In distributed databases, managing schema changes across multiple nodes and regions can be challenging. The concept of distributed DDL, data definition language, replication addresses these challenges by ensuring that changes to the database schema are consistently applied across all nodes in a distributed system. Overview of distributed DDL. 1. What is DDL? DDL refers to SQL commands that define the structure of a database. Common DDL commands include create, alter, and drop. 2. Why distributed DDL? In a global-scale distributed system, different nodes may need to reflect the same schema changes to maintain consistency. This is especially important for applications that require high availability and fault tolerance. 3. Challenges with distributed DDL *. Consistency *, ensuring all nodes have the same schema. Latency *, schema changes can take time to propagate across regions. Conflict resolution *, handling situations where schema changes conflict. Key concepts. Global schema management *, a central service or protocol to manage and propagate schema changes. Eventual consistency *, a model where schema changes are eventually consistent across all nodes, even if they are not immediately reflected. Versioning *, keeping track of schema versions to manage updates and rollbacks. Implementation example. Here's a simplified example using a distributed database system like Apache Kafka and a PostgreSQL cluster. We will simulate distributed DDL replication using a message broker to propagate DDL changes. Prerequisites. Apache Kafka, PostgreSQL, Python, for scripting and automation. Step 1, set up Kafka. Install Kafka and start the broker. Bash. Download and extract Kafka. UGIT https://downloads.apache.org/kafka/2.8.0/kafka_2.13-2.8.0.tgz. tar xcf kafka_2.13-2.8.0.tgz. cd kafka_2.13-2.8.0. #start zookeeper. bin/zookeeper server start.sh config/zookeeper.properties. #start Kafka broker. bin/Kafka server start.sh config/server.properties. Step 2, create a topic for DDL changes. Create a Kafka topic that will be used to send DDL commands. Bash. bin/Kafka topics.sh create topic DDL_changes bootstrap server localhost 9092 partitions 1 replication factor 1. Step 3, produce DDL changes to Kafka. Create a Python script to send DDL changes to the Kafka topic. Python. From Kafka import Kafka producer. Import JSON. Initialize Kafka producer. Producer equals Kafka producer, bootstrap_servers equals localhost 9092. Value _serializer equals lambda v, json.dumps, v, .encode, utf-8. Function to send DDL command. Def send _DDL_command, command. Producer.send, DDL_changes, command, command. Producer.flush. Send a DDL command. Send _DDL_command, create table users, ID serial primary key, name varchar, 100. Print, DDL command sent. #####. Step 4, consume DDL changes and apply to PostgreSQL. Create a consumer script that listens for DDL changes and applies them to the PostgreSQL database. Python. From Kafka import Kafka consumer. Import Psycha page 2. Import JSON. #initialize Kafka consumer. Consumer equals Kafka consumer, DDL underscore changes. Bootstrap underscore servers equals localhost 9092. Value underscore deserializer equals lambda x, JSON.loads, x.decode, UTF-8. Auto underscore offset underscore reset equals earliest. Enable underscore auto underscore commit equals true. #connect to PostgreSQL. Con equals Psycha page 2.connect. Name equals test user equals your underscore user password equals your underscore password. Cursor equals con.cursor. #consume and execute DDL commands. For message in consumer. DDL underscore command equals message.value command. Try. Cursor.execute, DDL underscore command. Con.commit. Print, F executed DDL command, DDL underscore command. Accept exception as E. Print, F error executing DDL command, E. Con.rollback. #close connections. Cursor.close. Con.close. #conclusion. This tutorial provides a basic framework for implementing distributed DDL replication across a global scale system. The example uses Kafka to propagate DDL commands to multiple PostgreSQL instances, ensuring that schema changes are consistently applied across the distributed database. #final notes. This implementation is simplified for demonstration purposes. In a production system, you should handle errors, retries, and ensure security. Consider using existing frameworks and tools like Debizium for change data capture, CDC, and schema management in more complex scenarios. By following this approach, you can achieve a more manageable and consistent global schema across your distributed database architecture.